Hey kids, Smath here. Got our video on Unit 2 progress check. Now, Unit 2 is ionic and molecular compounds. This is another pretty standard unit. We just finished atomic structure. Now, from atomic structure, we come into ionic and molecular, kind of a little bit about bonding now. Pretty big unit. Should definitely be on this year's exam. Traditionally, this is a unit that's another one that's covered between 7 and 9% of the exam. To be honest with you, there are usually 9 units, so each one is about between 7 and 10%, depending. Okay, so this one we should be expecting a bunch of bonding going on. So answer the following questions about N2 and N2H4. N2H4 is hydrazine. It's a rocket fuel. That's very cool. In the box below, draw the complete Lewis electron dot structure diagram for N2. We can do this. We don't even need a reason why. You should draw something that looks like this. Triple bond, one lone pair on each side. Done. That's A. Okay, I don't know how you would look different unless you ended up setting this up the way we set it up in class and showed it to you and taught it, and it would still be right. It would just be weird, but where you made this bond, and then created the banana bond. Still the same thing. There's still a triple bond and a lone pair. Now, B says, based on Lewis electron dot diagram that you drew, is N2 polar. This is one of the few cases, kids, where we have lone pairs on the central molecule. And the answer is this molecule is non-polar. It is completely symmetrical in electron distribution. Which means the electrons are evenly spaced out. So there's no way for one side of the molecule to be more negative, one side of the molecule to be less negative. The electrons are equally distributed. Now, that gives you a good answer for B with a short, sweet explanation. Don't give them more than they ask for. Just explain why. It's nonpolar because it's symmetrical. Not good enough. What's symmetrical? The electron distribution is symmetrical. Okay, let's be succinct in our writing. The following shows the potential energy diagram for 2 nitrogen molecules. Now, this one is a really sneaky question. Actually, C and D, I think, are 2 of the harder questions in these review units. It's the simplicity of them. On the graph, indicate the distance that corresponds to the bond length of the N2 molecule by placing an X on the horizontal axis. Now, let me show you the right answer. Your X should go right there. How come? Because that's the x-axis. It asked for the X on the horizontal axis. What are most of us going to do? Say, hey, show us where the bonding occurred. Oh yeah, the bonding occurred right down here. Sorry, yellow. Right there. There's my X. No. Yellow X, bad. That's not going to be considered a correct answer. It's not on the horizontal axis. Yes, it's where the bonding occurred, but you did not answer the question. So please, we're going to be real finicky about this because it's a short test. There's no room for silly mistakes on a question that I know you guys understand how to answer. Let's just be careful in how we read the question and give them a quality answer for it, okay? Now, D is a really hard question. Only from conceptually, not that it's that difficult to read, but it says on the graph, on the graph, which shows the potential energy curve of the nitrogen atoms, sketch a curve that corresponds to the potential energy of two oxygen atoms versus the distance. Now this one's going to be a little bit more difficult, okay? Because what we need to do is we're going to start up top. Whoops, kidding. Let's come back to our blue. We're going to start up top. It's going to come down and it's going to come back up. It should be skewed to the right and it should be skewed a little bit higher than where I put my bad in a bad place. That should be my oxygen. Why should it be higher? Because we know that N has a triple bond. Oxygen only has a double bond. Therefore, the triple bond should be stronger. Okay. And it should be skewed a little bit further to the right because the internuclear distance is going to be a little bit further apart. Remember, as we get more bonds, the bonds get stronger and the bonds get shorter. And I think that's going to come up here in a minute when we get down to F maybe. Okay. Okay, so now we've drawn that. E is a very simple question, and I'd hate for anyone to lose any points on this. A sample of N2H4 has a mass of 25 grams. Identify the numerical quantity that's needed to convert the number of grams to the number of moles. You do not need to do the actual calc. Well, what number are they talking about? What number do we need to get it from grams to moles? They're talking about molar mass. And we all know that, right? So what do we have to do? We need to say N2 is 14 times 2, that's 28 plus 4. What number are we talking about? We need to get 32 grams. The numerical quantity that's needed to convert the number of grams to the number of moles. Notice I put moles on top. Odds are, I would probably think that if you said 32 grams per mole, they would expect you to that you would know that. Or best bet, I would set it up. Here's my bestest answer. I would show the setup. I would guarantee you that would get you full credit points. Okay. Now let's look at F. F gives us the hydrazine, the N2H4. That's Lewis dot, based on Lewis dot structure of both of these. So remember, we have this one now, and up top, we had our triple bond N. So if we don't get that nitrogen molecule triple bonded, we're going to have problems for the rest of this problem. Sorry. Based on the Lewis dot diagrams, compare the length of the nitrogen-nitrogen bond in N2. So the N2 bond is shorter. Compare. They didn't ask for an explain. They asked for a compare. So the N2 bond is shorter than the N2H4. Based on the Lewis dot diagrams, compare the strength of the N2 bond. The N2 bond is stronger, shorter and stronger. You guys know this. N2H4. Then it says, identify the hybridization of the N atoms in N2H4. So what I see, just look at one of them. It doesn't matter which one. Pick one. I see 3 bonds plus 1 lone pair. That gives us 4 electron pairs. sp3 is that hybridization. Plain and simple. We should like that. And I believe that gets us to the end. So that's progress check number 2. molecular structures, not ionic ones this time, but a good comparison of molecular structures. Drawing Lewis diagrams, hybridization, bond length, bond strength. Great review of that bonding material. I'm Smath. I hope this video helped you.